In this segment, we're going to discuss the different types of inheritance that can be used for a base class to a derived class. So we're going to be looking at public, private, and protected inheritance. And I just want to point out one key aspect is here when I'm talking about these access keywords, public, private, or protected. Now I'm talking about the keyword right before the base class when you're specifying the inheritance. So it's the class student, the colon, and then the keyword public says this person class, it's going to inherit publicly from the person class. So here, when we have the keyword and then the class, we are specifying that student inherits from person publicly. When public inheritance is used, the public and protected data members of the base class are available to the child class and the grandchild classes. And the public base class members and functions are accessible to third-party classes and functions. And what I mean by that is we see that Tommy inherits publicly from student. Publicly is a student that inherits publicly from person. You'll notice that inside main, we instantiate this S1 student object, and then we call getName. So getName is not defined in student class. It is inherited from the person class, and we can call it directly because of the public inheritance. So because student inherits publicly from person, the public function of student in this example, getName, is accessible to main. Now, for private inheritance, and when we're specifying private inheritance, once again, we are placing the keyword private after the colon in this definition of the class and the name of the class. So in this specific example, we have the person as we've had before, and now we are specifying that this faculty class inherits privately from the person class. So what's happening now? When you have private inheritance, the public and protected functions of the base class are only accessible to the derived class, the directly derived class, the child class, but they are not accessible to the grandchild classes or any third-party clients such as main functions or any third-party classes. So let's see specifically what we mean by that. So faculty inherits privately from person. Because of that, faculty can call the getName public function from person. However, main cannot call this third-party public function. So this cannot be called because it's private. So basically, the faculty objects are not recognized by the compiler as person objects anymore when we do this. So it cannot call the getName function. Main cannot call the getName function. But also, you'll notice that now inside the derived class, so now we have a class called visiting that inherits publicly from faculty, and even this grandchild class cannot access the getName function, which is derived through person. It is not accessible. This will not compile. So when private inheritance is used, the public and protected base classes, data members, and functions of the base classes are accessible only to the directly derived child class. They are not accessible to the grandchild class or any other further down the hierarchy of inheritance, nor are they accessible to third-party classes. So as though that derivation, that base class, no longer exists for any classes that are inherited from it. So now with protected, it's slightly different in that with protected inheritance, and here we have the keyword, when we're using protected inheritance in the class specification, we give the name of the class that we're defining, the colon to indicate inheritance, the keyword protected, and then the name of the class, that's the base class. So in this case, we're saying the class student is inherited from person using protected inheritance. So here's a student uses protected inheritance for person. And the key difference here is that when you use protected inheritance, the public and protected members of the base class are accessible to the derived class and to the children of the derived class. So it's accessible to the child class and the grandchild class, but it is inaccessible to third-party classes or clients. So let's look at what this looks like. So here we have student, which inherits using protected inheritance from person, and then we have honor student, which uses public inheritance from student. Now, because we used protected inheritance, if we go to main, so we instantiate two student objects, S1 Ahana and honor student object Emily. If we try to call the getName function, so getName is public in the person, but because we used protected inheritance, we can no longer access that from main or any other class. So because it's protected inheritance, the compiler will not recognize those student objects as person objects. So it's a way to protect the inheritance with the base class. In contrast, you might notice that the student object can access the base class public and protected member functions and data directly. But here, and this is the switch from private inheritance, is that here you'll notice that the grandchild, the class derived from student, honor student, can also access the data. So you'll see if it's the child class or the grandchild class, it can access the public or protected data member functions from the base class. That's the main difference. So this is, you can think of protected inheritance as maintaining protection for anything outside of the chain of derived classes or inheritance. So now let's recap what's happening when we look at these three member functions in the base class. So we have a base class with three member functions. F1 is public in the base class, F2 is protected, and F3 is private. And now we are going to derive a child class called child A using public inheritance. When we do so, in the grandchild, which is the child GCA, which inherits publicly from the child of A, you'll notice that the grandchild can access F1 and F2, the public and protected functions, but it can't access the private, and neither can the child class. But you'll notice that for the third party function, which is main, it can only access the public. So third party can only access the public. Any derived class and I'm just going to say in the inheritance chain, can access the public and protected. But you'll notice that they cannot access the private. If it's private, it's in the base class, the child and the grandchild cannot access them. Okay, now let's take a look at what happens with protected inheritance. Okay, same functions again, F1 public in the base, F2 protected, and F3 private. When we use protected inheritance from the base class to the child class B, and then public inheritance to the grandchild class GCB, you'll notice once again that when it's protected, that the derived classes can access the private, excuse me, sorry, this should be public and protected, public and protected. However, you'll notice in the third party, nothing is accessible now. So it is as though this once public function now becomes private. So when it's protected, nothing is accessible. What was a public function in the base class has now become private to third parties. Now, finally, when we use private inheritance, the access stops with the base, the first class derived from the base class. So let's just take a look. So the child class C can access F1 and F2, the public and protected in the base class. But when we get to the grandchild class cannot access anything from the base class. So you'll notice that here, from the grandchild class, and say any not directly derived. As well as third party. So third party functions or classes, nothing is accessible in the base class. And so that's the key takeaway. So you can think of the compilers that once you use private inheritance for child C from the base class, it's like even child C is no longer recognized as an object of the base class for the compiler. So then as you get further away from child C, you cannot use any of the base class functions or data members, and in main third parties, you cannot use any of the data members or functions from the base class. But it is true that the child class C can access F1 and F2, just the public and protected data members and functions. That's fine to do whatever work it has to do. But going any further down the inheritance chain or any third party, it's as though base class is completely hidden. So that's just to motivate some of why we use private inheritance. So now, just to summarize very quickly what's happening, the interplay between inheritance and access, you'll notice that when we have public member functions or data, it's accessible to all users. When you have public or protected, those are only accessible to the derived class's members. For the class's own members, you'll notice that everything is accessible to it. So a class's own member can touch everything. The derived can only touch public and protected. and the third-party users, either other classes or even other functions, can only access the public members. Now, how does this change when we're using base class inheritance? So if the base class inheritance is public, that means that all of the public members can be used by all functions. If it's protected, then what happens is that the public and protected members can only be accessed by the derived classes and their grandchildren. So it can only be accessed by the inheritance chain, only within, I'd like to call this the inheritance chain. But if the base class inheritance is private, that means only the directly derived class can access the public or protected data members of the base class, and no other classes can access that data at all. So this is just a quick summary of the interplay between inheritance and the access to the data members in a class.